need to start at 1, right? So right now, if you plug 1 into this, where are you going to be? That's this list, right? 2n? These are the even numbers. It's this list, right? These numbers are these numbers, but just you need to take 1 away from each one of them, right? So 2n, take away 1, and that'll give you all the odds starting at 1. Good. How about 17, 19, I guess I'll give you another one, 23. Go ahead. I'll get you next time. Yes. 2n plus 15. Yeah, they jump by 2, right? Each one jumps by 2, 2, 2, 2, 2. But you need to make sure you start at 17. And so when you plug 1 in here, you're going to get 17 to start. Now look, we're assuming n starts at 1, right? And when we first start talking about sequences, n will always start at 1 for us. As we progress through this chapter, n will be able to start at other places. But for the general idea of a sequence, we start at 1. For now. Yes?
So when you look at sequences, you look at like the gap between the numbers and where it starts? And
for these sequences, the gap between numbers is what's really dictating everything for us, right? Let's do something different. How about this? Who wants it? Go ahead. 4n plus 1. Everybody? Yay or nay? Yay? Are they increasing by, are each one of them increasing by 4?
Yes.
Yes? But we need to start at 5. So we do 4n, that jumps, this is going to make us jump by 4, and we add 1 so we can start at 5. Yeah? I like it. With this. Who wants that? Go ahead. Did you? I thought you raised your hand. No? No. 5n minus 6. Does that look right, everyone, or no? N's going to start at 1. Let's see. Do these jump by 5?
Yes.
Yeah, that jumps by 5 there, right? 5, 5, 5. But we need to start at -1, so we're going to put 5n minus 6. All right, good. I think y'all are getting this, I hope. Yeah. How about this? Is that jumping by the same amount each time?
Yeah.
Sure. I mean, to go from here to here, to make 1 turn into -1, you have to subtract 2, don't you? Subtract 2, no, that's not subtract 2. That's subtract 2, add 2, subtract 2, add 2, right? That's not the pattern we have here, is it? This is something completely different. Everything I've shown you up to this point have been lists of numbers that always keep increasing at the same amount. And then we're just like shifting it left or right. Does that make sense? This is not doing that. You want to try? Well, hold on. Is there anyone else that hasn't responded? You've responded or no?
No.
No? Okay, I thought you had.
1, 2n minus 1.
A sub n equals, what did you say? 1?
2n minus 1.
2n minus 1. Well, if I plug in a number here, right? Like let's say I plug in 1, I'm going to get 2 minus 1, that's 1, 1 to the 1 power. If I plug in 2, I'm going to get 4 minus 1, that's 3. 1 to the third power is still 1.
So maybe -1 instead, have to change the power.
Say again?
Maybe start with a -1.
Ah.
Would need to change the power.
Okay, -1, and then make that power what?
To the n power.
Just n. Just n. Look at it. Look at it. This number right here is -1 to the first, oh wait, sorry, hold on, not n. Sorry, we're starting, it can't be n. What is it? To get a positive number, you need to get an even power up here, right? To get a negative number, this would have to be an odd power. Then even, n plus 1. I'm sorry, I thought we were doing a different list, and I looked up there and realized it won't work. Okay, look, this, if you're confused, let's just look at this, okay? Let's just start plugging things in. If we plug 1 in, right, this is -1 to the 1 plus 1. This is -1 to the second power, and -1 squared is 1. Then we do a sub 2. Well, that's going to be -1 to the 2 plus 1. That's -1 to the third, and -1 times -1 times -1 is -1. So that gives us our second number. And what's going to happen is I'm going to keep counting, I'm going to keep adding a number to this. So it's going to be 2, 3, 4, 5, 6, 7, 8, 9, right? So what you're going to have is even power, odd power, even power, odd power, even power, odd power, back and forth, back and forth. And anytime you raise -1 to an even, you get 1. Anytime you raise it to an odd, you get -1. Really important. Yes?
So where did that +1 come from? N plus 1?
Where did it come? I don't know. Georgia? Georgia, right?
Yes.
Yeah. Well, do you see why n won't work? Look, if you try just n, what happens? When you plug 1 in, what would you get? -1, imagine that's not there. -1 to the 1, right? Which would be -1, right? You don't want it to be -1, you want it to be +1. So we added 1 so that when we plugged in 1, we didn't get 1, we got 2. And when we plug in 2, we don't get 2, we get 3. Yes? I have a question for you. Is that the only answer? Or is there another, could you have come up with a different formula that would have done the same thing? Like, could I have done this? Would that have worked?
Yes.
Yes, because if I plug in 1, what's the power going to be? Even, right? 6, right? If I plug in 1, I'm going to get 6, and that'll be an even power, give me this. And when I plug in 2, I'm going to get 7, that's an odd power. When I plug in 3, I'm going to get 8, and that's an even power. That would create the same thing, wouldn't it?
Any odd number.
If I take n and add any odd number, I should get that list. Would this have worked? What happens if I plug 1 into this? What do I get? -6. What's -1 to the -6? Well, that's 1 over -1 to the +6, right? That's what it means to have a negative exponent. And then what's -1 to the +6? 1. What's 1 over 1? 1. So that would work, right? Now what happens if I plug in 2 into this? So this is what happens when you plug in 1, right? This turns out to be 1. What happens when you plug in 2 here? You get -1 to what power? -5. That's 1 over -5 to the 5th. What's -1 to the 5th? -1. What's -1 over -1? Or sorry, what's 1 over -1? -1. It works. Yes?
But that one does not work when it gets to 0. Or the,
Would it?
Sorry, 7.
Would it?
No, because when you do 7
It does work.
It does, oh, yeah.
Because negative 1 to the 0 is 1. So it's the same as being raised to an even number, and 0 is an even number, right? 0 is an even number. So we actually could say, now this is the one we use the most, okay? That's the one I'm going to use almost exclusively. But later on, we're going to run into something, and we're going to have to do something. And it's important that you understand that this formula could look like this. Negative 1 to the n plus or minus any odd number, right? If I do n plus 5, n minus 7, doesn't matter if I add or subtract an odd number up here, this formula will give me that list. Okay? We call this an alternating sequence. It's in the definitions in the notes. This is called an alternating sequence because what it does is it changes signs. Alternates in sign. How are we doing? 20 minutes. All right, how about this? What if I want an alternating sequence, but I want it to start at negative 1 instead of positive 1? I didn't hear that. What?
It would just be even.
So, yeah, how do you do this, son? What's the formula?
-1 to the n plus even.
Plus or minus an even number. So, why just n? Well, plug in 1 right now. What do we get? Plug in 1, you get negative 1. Plug in 2, you get positive 1. Plug in 3, you get negative 1. 4, positive, right? That would work. This would also work. Right? Because if I plug in 1, right? 1 plus 8 is 9. Negative 1 to the 9 is negative 1. Plug in 2, that's 10. Negative 1 to an even power, that'd be this one. See it? So in general, this is the one we use the most, all right? But in general, plus or minus an even number.
Would those be for like sine and cosine? Or like alternating or?
Sine, I'm not sure what you mean by sine and cosine. The sine and cosine functions?
The range goes from 1 to 1, 1.
Well, do you remember when I started this, I said that all functions have some polynomial that goes forever? The sine function has this thing goes forever. It is an alternating, the signs on it alternate. That's the only thing I can say. It doesn't have to do with the up and down. Because when the sine function, it does go from positive to negative, but it's not like an immediate switch, right? It's like it's positive for a while, then negative for a while, then positive for a while, then negative, right? I have the screen off. Hang tight, we'll see that in a little bit. How about this one? Volunteers, please. Are you raising your hand there? What are you thinking? You said n to the power of 3? Is that what you said? N cubed? You have it, it's the other way around. These are all powers of 3, right? This is 3 to the first power. This is 3 squared. This is 3 cubed, right? This is 3 to the 4th power. So do y'all see they're not jumping up by the same each time, right? From here to here. So this would be 3 to the power of n. I mean, you said n to the 3rd. I don't know. I mean, that's the other way around. It's 3 to the power of n. Do y'all believe that? Do y'all see it? How about this one? Oh, nope, 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 nope. influence that? Go ahead. You have. Let's see. Someone else that hasn't won it? Go ahead.
3 to the power of the n minus 1.
There you go. 3 to the power of n minus 1. The minus 1 is up here in the exponent, right? Not minus 1 out here. It's minus 1 up here. So now, all we've done is I added one more number to this list, right? The one that was in front of this one, which is 3 to the 0, right? You have to see that. This is 3 to the 0. This is 3 to the first. This is 3 squared. This is 3 cubed. This is 3 to the fourth, right? So all of these have the same thing in common. 3, 3, 3, 3, 3. The powers are 0, 1, 2, 3, 4. Do you all see the powers 0, 1, 2, 3, 4 is just that formula right there, n minus 1? No? This one usually gets people. Probably won't get you because I'm already kind of hinting towards it here. But what about this? 1/9, 1/3, 1, 3, 9, 27. N minus 3. What do y'all think? Does that work? This is 3 to the first, 3 to the second, 3 to the third, 3 to the 0. This, you have to recognize, is 3 to the negative 1. This is 3 to the negative 2. And so these are all powers of 3, but we're starting our list, our powers at negative 2, so you have to use n minus 3. Yeah? There we go. Now we're getting somewhere. I'll take a volunteer first. This is open to everybody.
It's something over 2n.
So you're seeing on the bottom, these are all powers of 2. So we probably are going to have a 2 raised to the n somewhere in here. I agree. What else do you see?
Cycling.
Sequence, right? This thing is alternating. Positive, negative, positive, negative, positive, negative. Can you make something switch positive, negative, positive, negative? Yeah. A sub n equals, okay, so 2 to the n on the bottom, right? 2 to the n on the bottom should take care of 2 to the first power, 2 to the second, 2 to the third, 2 to the fourth, right? How do we make it alternate starting with a positive number? We would need up top here negative 1 to what power? N plus any odd number, right? 1? That should make the first term positive, second one negative, third one positive, fourth one negative. So now, look at your numerator numbers, but ignore the positive and negative because you've already taken care of that. So just look as 5, 9, 13, 17. 4, right? Those are going up by 4 each time, starting with 5. So what do I need? 4n, right, because it jumps by 4. But I need to start at 5, so when I plug in 1, I better get 5. If I plug 1 into that, I'm not going to get 5. What do I need to put here? Plus what? 1. Put that in parentheses. That's it right there. So in hindsight, here's the way I'm looking at this. I look at it and say, hey everyone, I've got an alternating sequence. Let me knock that out first. That's this right here. Now I don't care about the signs anymore, okay? Now I look at the numerators and denominators separately. Notice the powers of 2. Those are kind of like glaring at me. 2, 4, 8, 16, right? Those are powers of 2. These are not even numbers. Not 2, 4, 6, 8, 10, 12. It's 2, 4, 8, 16, right? Powers of 2. So that's 2 to the n. But the numerator is jumping by 4 each time. So I use 4n, and then I have to start at 5, so 4n plus 1. There it is. Yes? No? Feel okay? How about this one? I feel like, I mean, we could spend all day on these. We already have spent a lot. Let me see if there's any more interesting ones here. We're going to get a lot more practice with this. Let's do one more. Okay, let's start with -3. Okay, hold on now. 1/5. -3 over 25. Positive 9 over 125. Negative 27 over 525. God, I hope I did that right. I was doing it in my head. So, yeah, I think it's right. So you're noticing that all the denominators here are powers of 5?
The first one has no denominator, so it's got to have a power of 0.
Yeah, so, okay, let me do this. I like this idea. You're noticing a pattern that this is like on the bottom 5 to the first power, right? The bottom of the next one's 5 squared. The one next to that's 5 cubed. And then 5 to the 4th, right? Keeps going. So that means that this one right here would have to be 5 to what back here? 5 to the 0. And 5 to the 0 is 1. Okay, so that seems like that's reasonable. What about the numerator? Well, we have alternating. Don't need to worry about the alternating, right? Because we can handle that negative, positive, negative, positive, negative. We can take care of that with a -1 to a power. So really just look at the numbers. 3, 1, 3, 9, what the hell? Powers of 3. So this would be 3 to the first. I think I screwed this up. 3 squared, 3 cubed. This would be 3 to the 0. This one, if we follow the pattern, would have to be what? 3 to the -1, which means that this should be 1/3. Oops, I messed up. You know what I was trying to do? I should have put a 5 here. I wanted to put a 5 on top and then a 3 on the bottom. That's what I should have done. But it's okay. So my mistake, change that to a 1/3. Now it works. That's what I get for making it up. Oh, yeah, that's just me being stupid. Okay, so if this is negative 1/3, now does it work? You see that? Because this would drop to the bottom. And that's already a 1 down there, so that would be that. All right, let's try and come up with the formula. A sub n. All right, let's take care of the alternating first. I always like to do that first. So it doesn't matter if I put this on the top or bottom. I can even put it out front. Negative 1 to what power? I can do just n, right? Because it's going to start negative. And then, this is the way I like to do it, I'm going to have my fraction out here. Look at the bottom. So 5 to what power? N minus 1. And then 3 to what power on top? N minus 2, because you need to start at negative 1. There we go. That would be the formula for that sequence. All right, we're going to get more practice with this. But we need to move on. And we have about 7 minutes, so I have enough time to at least talk about this. Factorial, we've talked about factorial already in this class. N factorial. By definition, this is equal to n times 1 less than n times 2 less than n times 3 less than n, and you keep doing that until you get down to a 1. And this is only defined for n greater than or equal to 0 and n an element of the integers. In other words, n here can only be 0, 1, 2, 3. Whenever we define the factorial in this class, we only define it for the numbers 0, 1, 2, 3, 4 forever. That's the definition of factorial. As an example, 4 factorial is 4 times, now you take 1 away from 4, 3, now you take 2 away from 4, 2, now you take 3 away from 4, 1. You stop when you get to 1. 4 times 3 times 2 times 1. That's what 4 factorial is. Yeah? You've seen that before? Yes? This right here? Oh, that's the number 1. So you're doing this multiplication times, and you stop when you get to 1.
What does this mean?
Sorry, this is the integers. So you know how we had the natural numbers a second ago? The natural numbers are the numbers 1, 2, 3, forever. Okay? The integers are the numbers negative 3, negative 2, negative 1, 0, 1, 2, and 3 forever. Those are the integers. So I'm saying for all integers bigger than or equal to 0. This way. I can't say natural numbers because the natural numbers don't have 0 in them. If 0 was in here, I would have just said natural numbers. All right, so this is the definition of factorial, yeah? Interestingly enough, well, in this class, we don't define this. Like if I ask you, what's 1/2 factorial, this makes no sense in this class. But this actually does have a mathematical definition. And maybe I'll share that with you next class. It has to do with a special function. Does anyone know what the factorial is like actually intimately connected to? There's another function in math? No? Maybe I'll share it with you next time. It's called the gamma function. No? No. It's anyway, I'll show you. There is a way to define that, okay? There's a way to define this that has nothing to do with this, all right? And what's cool is the way we can define this is actually whatever we use, this definition involves an integral. Okay, it involves an integral that I believe goes from 1 to infinity. Somehow we define the factorial to be some integral. And, oh no, I think it goes to t. I don't know, I need to go back and look, I'm sorry. But what's cool about it is that when we define it that way, then this still gives us the same answers. Like we get the same answers, like 4 times 3 times 2 times 1. You get that answer using this definition and that definition. All right, I'm not going any further with that. What I wanted to see here, wanted to show you is this one formula that we're going to use a lot. A lot. So put a star next to it. If you ever have n plus 1 factorial. So let's say you have some number plus 1 and you want to do factorial. What this means by definition is that you're going to start with n plus 1, right? Just like over here you started with 4. If this is n plus 1, you start with n plus 1. Then you multiply that times 1 less than that. That's n. Then you subtract again. So what's 1 less than n? N minus 1, right? What's 1 less than that? N minus 2. And you keep doing that until you get down to 1. Do y'all follow that? But this, from here to here, is just n factorial, isn't it? So I can write this as n plus 1 times n factorial. Believe it or not, that's actually a very important formula for us. I'll show it to you. I'll show it to you not the way we're going to use it, but I'll show you what that is here with this right here, 4 factorial. What this is saying is if we had 4 factorial, we could write that as 4 times 3 factorial. Right? 4 factorial is 4 times 3 times 2 times 1. 4 times 3 times 2 times 1. You see, it's almost like you're peeling off the first piece, and then you're counting down the rest of the way. All right. As far as homework, we really, for 8.1, we have to spend a whole another day in 8.1. All right. So there's nothing out of the textbook I want you to do. Work on that bonus problem, or not the bonus, the quiz problem with the pipes, and then I'm going to send you a couple of problems where they're just the sequences and you come up with the formulas. And that's just going to be, it's not going to be turned in, it's just for exercise, all right? I'll send that to you probably in the next, 24 or 48 hours. So just check your email. Other than that, have a great weekend.